want to start talking about survey design. You will see lots of commonalities between survey design and interview design, which is why this is sort of a natural follow-up topic to what we've been talking about before.
This great. So
okay. This is the list of things I read to put together this material. They're all in our shared readings folder, and you can go look at the original sources, or you can have the LLM summarize them for you, or whatever it may be. But this is sort of very useful stuff to read besides just the lecture today. Oops. Okay, so now, why do we run surveys at all, and what are they good for? They can be good for just getting a sense of frequency or prevalence of certain practices or phenomena or what have you. So they're typically good at this. Think of election polling. That's one example of this kind of goal for running a survey. They can be good for measuring and quantifying relations between variables. If you have good ways of measuring those variables with a survey, they could be good for that. People often use them for that. And similarly, we're comparing across subgroups or populations or what have you. Any of the previous two things, for example. Okay, the most common type of survey is called a probability sample survey. This is where you survey only a sample of the population, but seek to generalize your findings to the entire population. Remember, we talked about two kinds of strategies for generalizing anything, any conclusion or claim or results earlier on a few weeks ago. Does anybody remember what we called the two generalization strategies? Statistical and analytical. Can you remind us?
Statistical is the probability. And the analytical is like applying the theories.
Right. So statistical is this. Again, we're coming back to it as another example. Analytical is one based on some theory. Thank you. Great. Okay, so as you're designing a survey, basically the main goal is to reduce the difference between the estimate produced using that survey data and whatever the true value of those variables is in the population at large that you're hoping to describe. The goal is to design a survey that is as accurate and reliable as possible. Okay, so what are some of the types of errors and how might we go about minimizing them? Number one, we talk about coverage error when, yes, what? Sorry. Oh, just a stretch. Yes. Talk about coverage error when we're thinking about who we end up surveying. So here the technical term is sampling frame. Sampling frame is the set of people from which I sample the survey respondents, or rather the set of people that I invite to participate to in the survey. And all kinds of questions around how might you construct this. Maybe a random sample is a very common approach. Maybe there are other approaches. We'll talk more about this. Anyway, coverage error talks about how representative this sample is relative to the population. We can talk about sampling error when we talk about the size of this sample. How representative is the sample of the population at large? And obviously, the smaller the sample, the less representative you can expect it to be. The larger the sample, the more representative. We'll see some measurements in a second. We talk about non-response error. This is one of the biggest, most common, most important kinds of errors that come up. Because, as you can imagine, not everybody you invite to respond to fill out a survey will actually do so. And that could be okay, but could also not be okay at all if the people that choose not to respond are fundamentally different from the people that chose to respond in some ways that completely bias your conclusions. Because remember, the goal of the survey is to ideally generalize your findings to the population at large. But maybe the people that responded to your survey are very different from the ones that did not respond to your survey. So whatever you generalize from this sample will absolutely not hold for the population at large because you're missing the input from these people that you didn't hear from. So it's very big source of error here. By the way, same for election polling. Okay, that's what the pollsters. That's where the money is, in being a pollster. It's figuring out who you're missing from your sample and how might they vote. Right. Okay, and then we talk about measurement error when we think about what we're actually measuring, what questions we're asking, and how valid and reliable these measures are. So we're going to see a lot of examples in a second. Here's an example of coverage error. So let's say you're running a landline phone-based survey, and you sample randomly people with certain digits in their phone numbers or something like that, and you call them up to ask them questions. So here, coverage error could occur because the people that have landlines, especially these days, who has landlines anymore? People that have landlines can be quite different from those that do not on a number of important characteristics, sociodemographics, socioeconomic status, and so on. Back in the olden days, the people with landlines were the wealthiest people. So if you only hear from them, you're missing out on the opinions of all of these other people who just don't have landlines. Or similarly, you can imagine surveying the population at large versus surveying CMU students. They're quite different populations. Okay, so context matters. Okay, sampling error. Right, one interesting thing here. It was surprising to me how few people you actually need to survey to obtain a reasonably reliable estimate of whatever thing you're measuring. Surprising how small the samples need to be. There's all kinds of online tools that allow you to calculate what an acceptable sample size is, given constraints like confidence level and margin of error. Confidence level and confidence interval, we're going to talk about this in a second. So anyway, you can as long as you have a rough sense of how large your population is, you can reliably estimate how big of a sample you need to survey. For example, let's say there's about 14,000 students at CMU. So, if you're satisfied with a sample with 95% confidence and 2% margin of error, I'm going to come back to what these mean in a second. You need to survey a random sample of about 2,050 students, and that will give you the ability to generalize within those parameters to the entire population of CMU students. Okay, so that's fine. Here's where it gets super interesting. The US population, 330 million people, roughly. So to get a sample with the same property that the CMU one, you only have to survey about 300 and some other people. Mind-blowing. Surprisingly small, right? Given the previous example. So to go from 14,000 people to 330 million people, in your ability to generalize, all you have to ask is an extra 330 people. Mind blown. Right? Amazing.
Why? I remember hearing about this during during the theoretical CS class about some sort of Chernoff bound that does not require much sample to survey a lot of people.
Because I guess it converges quite quickly to the mean value of whatever estimate. Yeah. So anyway, so this was amazing, right? And yeah. Another thing that's amazing, if you're slightly less permissive or relaxed with your sampling criteria, as little as 100 people would give you a, not embarrassing, a good quality sample, 100 people of the entire US population. Crazy. That's pretty cool. Okay, so one quick aside about confidence level and confidence interval. You will hear these terms used a lot. So confidence interval, also known as margin of error, is the plus or minus figure that you see reported with all of these sample sizes or estimates from surveys or samples. And obviously lower is better. You would like to have a lower margin of error if you can. For example, if the confidence interval is 4 and 47% of your sample answered X, then you can be sure, I'm going to come back to this in a second, can be sure that among the whole population, between 47 minus 4 and 47 plus 4% of the population would have answered X. Okay. That's one. That's the margin of error. The other one, the confidence level, this tells you how sure you can be, but this represents how often the true percentage of the population who would answer X lies within the confidence interval above. So obviously higher is better. So, for example, if I draw a different sample from the population, right? If I keep doing this, how often would the true value that I'm trying to measure be found in that sample, right? So ideally, every time, but higher is better. But usually people settle for something like, 95% of the time, the true value should be in that sample. And this is sort of how you think about this. That this confidence level tells you how sure you can be, and confidence interval tells you how far you are from the true value. Okay. So you want lower margin of error and higher confidence level, ideally. Okay. This is also what, coming back to these kind of online calculators and tools, what you see, that the higher your confidence level, and the lower your confidence interval, your margin of error, the larger your sample needs to be. That's the idea. Okay. And then you sort of play with these parameters and you arrive at some acceptable sample size, and that's what you run your survey on. Make sense?
Is this theory applied to every area or some specific?
Yeah, so this gets hairy. I don't actually know how to do this in general. Applies to this scenario where you have one question and you're trying to estimate the true value of that variable. Now, usually in a survey, you ask all kinds of things. So, I'm not sure exactly how these start interacting and how the sample size that needs to vary as you're asking different kinds of things, each with their own measurement errors and so on. So it gets complicated. I don't know how to do this more generally, but your intuition is right. Yeah.
So both of these are sort of based on the population size or sample size, and
Population size.
it doesn't matter if everybody you sample answered exactly the same thing, this is more deviation.
It does matter, so I think there's some normality distribution assumptions or something like this for something here. There's some distribution assumptions for the population. And under different distribution assumptions, then this doesn't work the same way anymore. Yeah, and I don't remember what those are. But it does matter. Okay. Right, so this was sampling error, non-response error. We talked about this. Right, we talked about this before, you know, if the people that don't respond are somehow fundamentally different from those that do, you get this type of error. Measurement error has to do with the questions you're asking. Do they adequately, accurately, precisely measure the concepts of interest?
Can I ask you a quick question about the previous section?
The non-response?
Sorry, before that, coming back to Harrison's question. If you want to use these things, do you have to argue that your data is normally distributed?
No, I've not seen people do that. I think what I commonly see is, you know, we want to survey whatever population of stakeholders, say developers, and there's 100 million of them. So we randomly sample, you know, 3,000 of them, thereabout, because that's how many we need for a sample, random sample with these characteristics. I haven't seen people do more sophisticated things.
Do you have any insight?
Yeah, I feel like once your sample is large enough, central limit theorem should ensure some sort of.
So it won't matter about the underlying distribution.
Yeah, the sample size of the mean. I think, like the stats, it was like, they said it was like 30 or something, like as long as you have like 30 samples.
For binomials, 30 is a little bit too small, but like if it's 3,000, it's usually it's enough to ensure some sort of normality.
Yeah, so this is worth reading more about. I don't quite know all the subtleties. But I guess the point is, a good study would have thought about this and would arrive at a sample size in a principled way, you know, based on characteristics of the population and whatnot, and would argue those things explicitly. A bad study would just arbitrarily survey 100 people without any justification why.
So are you saying like there's multiple methods to calculate the sample size?
I think so, yeah.
Is there any name for the one you just mentioned?
Just sample size calculator is the default standard one. So just Google sample size calculator.
It seems like there would be a bunch of different combinations of confidence level interval that are valid candidates curve.
Yes.
Is there like any justification for like which one you report if you're just reporting a point? Like if you're gonna report a single confidence level, a single confidence interval, like what part of the curve do you sample?
So commonly people do this. They do 95.5 or 99.1. These are just common, just like 5% is a common arbitrary cutoff for p-values. This is the same way.
Okay, so you fix your confidence level and figure out what the confidence level is.
That's right. Yeah. But there's, other than they're common, I don't know why people choose them. Maybe they're nice round-ish numbers in a way. Okay. Right, so here, back to measurement error and the validity of those. Let's say you want to use the household income of your survey respondents in the previous year as a measure of household wealth. You can ask them what range their household income was in the previous year or something like that. And that's important for whatever you're testing. This is arguably an invalid construct because it is biased against people that have retired, whose annual income very likely decreases after retirement, but their wealth may not. Okay, so if you're using this measure, household income in the previous year as a measure of wealth, you should be aware of this, at least of this one systematic bias that is built into the measure itself. Okay? And this threatens the validity of that construct. Okay, I want to give you an example. So how do you get people to respond to a survey? This was a really amazing example of a survey. I really love telling this story. Was a survey of 600 PhD students done at Washington State University about their dissertation work and graduate training. And so the amount of effort the researchers went through to increase the response rates to the survey was just amazing to me. So here is a timeline of what happened. You can see on the x-axis is time, different actions and events that happened, the researchers took. And on the y-axis is the response rate. So now here, it's a fixed population of PhD students. They know exactly how many there are and who they are because they're all enrolled, right? So they can very precisely estimate their response rate. They know exactly what the denominator is, okay? Which is why they could do this. So here's what happened. They started with a invitation sent by snail mail in an envelope by USPS with a URL printed on the piece of paper in the mail, snail mail, of the where they could access the survey, and $2 bills in the envelope. Okay, cash. Yeah, of course. Yeah, you can.
I received it here in Pittsburgh or something. I don't remember.
You're not supposed to send cash to the mail.
Oh, I see. Maybe they could do checks. I suppose they could do checks.
Yeah.
Do checks. Then, I don't know, a few days later, they sent an email to everyone again and asking them to fill out the survey. I'll show you what the text of these invitations was in a minute. Then about a week later, they sent another email reminder. So you can see, the first thing, the first letter, the invitation got them about 8% response rate. The email did wonders, maybe because people just don't check their physical mail that much anymore. The email did wonders, got them up to about 50%. Second email also made quite a dent. Then they printed out the questionnaires and they mailed them to people again. Okay. With something like, I'll show you the actual wording, something like, if you prefer to fill this out on paper over responding to it electronically, here's a paper version and here's a return envelope and so on. Just please fill it out and mail it back to us. Okay. So this gave them another 3% or so response rate. And then they sent another final email after that, asking people to do this, reminding them to do this yet again, which gave them a little bit more still. So in the end, they got almost 80%, more than 3/4 of the PhD students ended up responding to this. And you can see how literally every one of these extra steps they took had some effect, had some impact on getting this number up. So, right, so here's the initial communication. Dear Jane, I'm writing to ask for your help with an important survey we're conducting and so on and so forth. It should take about 10 minutes to complete, service confidential, et cetera, et cetera, et cetera. we very much appreciate your help. And as a small token of appreciation, here are $2 enclosed as a way of saying thank you. Okay, cool. Then email, dear Jane, earlier this week we sent you a letter asking for your help. I'm following up with this email to provide you an electronic link to a survey website, should you prefer to do it electronically instead of filling it out on paper. The results will help us better understand the needs and experiences of students, et cetera, et cetera. Your participation is very important, and we appreciate you considering our request. So, as an aside here, the $2 thing in the beginning is really not random. They thought very carefully about what they were doing. There is this theory of social reward with modest incentives that's been tested a bunch of times. This is a study comparing response rates between 3 groups: control group, no incentive at all, the same survey, right? And people were randomly assigned to the different groups. A second treatment group, people were given 50 rubles. This may have been in Russia, so less than $2 at the time, together with the survey request, in much the same way that you saw the $2 being given to the students. Third group, people were promised a greater amount of money after filling out the survey if they return it, but nothing given upfront. Okay, the promise of a greater reward versus the smaller cash in hand at the beginning. Guess what happened?
Highest response group,
Which one?
second group.
Second group? Yeah. Anybody vote for anything else? Group 1? It doesn't matter, you're saying it's the same, basically.
Chaotic can go for 3. I think 3 because my friend did a workshop paper that found that people were more likely to go for the raffle with the big money instead of like being guaranteed low.
Okay.
It's not a raffle, like it's a guaranteed.
The bigger number.
That's true.
It could have been raffle, could have been. I don't think they tested raffle. This was guaranteed. Yeah.
Third group.
Okay.
I think people don't think about it. Never use it.
So you're sort of all right in a way, except Taylor. Sorry, Taylor. The prepay small amount, better response rate than the guaranteed larger amount. But really combining both gave them, I guess there was maybe 4th group here that combined both. Or maybe there was an overlap between groups or something, I'm not sure. Combining both gave them the highest response rate, like giving them something upfront and promising something at the end if they fill it up. Okay. So anyways, it's super interesting. Now think of, obviously you can use money if you budget for it and your project allows this and your IRB allows this and whatnot. Another thing you could think of doing, I think the same mechanism holds, is giving people something of value to them with the survey invitation email or whatever it is, when you invite them. And often what we've done in our group is giving them personalized analytics that we have collected as part of the research we were doing that applied only to them. We told them something interesting about, in my case, it's often open source software developers. We told them something interesting about their contribution patterns or their activity or their history of contribution or what have you, something that they wouldn't have known otherwise unless they did the same analysis we did. But we gave them something interesting when we invited them to participate in the survey as a way to make it more interesting for them and maybe to trigger this social reward mechanism. So I'm going to pause here.